Hey, this is Math 105 section 6.4. Now we're continuing our discussion of inverse sine, cosine, inverse trig functions, but from our triangle approach. Okay, so let's first look at the sine function. Remember, we restrict the domain of the sine function to angles theta, where we're between minus pi over 2 and plus pi over 2. Okay. And then we can see on this domain, the sine function attains each of the values between minus 1 and plus 1 exactly once, and then it is 1 to 1. Okay. So we restrict our domain. Okay. Theta between minus pi over 2 and plus pi over 2 for sine. Okay. For cosine, it's between 0 and pi. For tangent, it's between minus pi over 2 and plus pi over 2. Note the difference here, though. We include minus pi over 2 and pi over 2 for sine. Okay, because we can go to, remember we can have a sine equal to 1 and minus 1, but we do not include minus pi over 2 and plus pi over 2 for tangent. Okay, so be careful of that, because remember it's undefined there. Okay, that's when cosine is 0, right? Okay, so remember our sine is y over r. We're talking about radius, right? Okay, instead of looking at a circle of radius 1, maybe of radius r. Okay, our cosine is x over r. Okay, and our tangent is x over y. Make that y over x. Okay, should be y over x there. Let me correct that. Tangent is sine over cosine, so that would be y over x, not x over y. So scratch that. Okay, and remember we defined, y equals inverse sine of x as being the same as x equals sine of y, and that comes from starting with y equals sine of x, right, as our original trig function, switching x and y to get the inverse, so x equals sine of y, and then we solve for y to get y inverse sine of x. And then the same for cosine and tangent, same deal. We start with y equals cosine of x, we switch x and y to get x equals cosine of y, and then we write y in this as inverse cosine of x. We start with y equals tangent of x, we change x and y to get x equals tangent of y, that's our inverse function, and then we get y by itself to get y equals inverse tangent of x. So remember, these are exactly the same. Okay, these mean the same thing for each of those. Okay, so let me just highlight that. Okay, inverse tangent, and we already looked at this in 5.5. Okay. Okay, so just to summarize, inverse sine, cosine, and tangent function. We have restricted domain. Remember, we used restricted domain of minus pi over 2 to plus pi over 2, including the endpoints for inverse sine. Restricted domain for sine of minus pi over 2 to plus pi over 2 for tangent, and 0 to pi for cosine. Okay, so the sine, cosine, and tangent functions on the restricted domains minus pi over 2 to plus pi over 2, 0 to pi, and minus 2 to plus pi over 2 without the endpoints respectively for sine, cosine, and tangent are 1 to 1, and so they have inverses. Okay. So the inverse functions have the following domains in range. Okay, so inverse sine, domain is minus 1 to plus 1. Range is minus pi over 2 to plus pi over 2. Okay. Inverse cosine, domain is minus 1 to plus 1. Range is 0 to pi, okay, including 0 and pi. Inverse tangent, domain is all reals. Remember, our tangent can be any real number, right? If we take the tangent of an angle. And our range is minus pi over 2 to plus pi over 2 without including the endpoints. Okay. Okay, remember we can call these arc sine. Inverse sine could be called arc sine. Same thing. Inverse cosine could be arc cosine, and inverse tangent could be all arc tangent. Okay. Okay, so let's look at some examples. First, inverse sine of square root of 3 over 2. Now, we're saying the sine of our angle is equal to square root of 3 over 2, and we want to find the angle between minus pi over 2 and plus pi over 2 where that happens. Okay. So the angle in the interval minus pi over 2 to plus pi over 2, whose sine is square root of 3 over 2. And that, in this case, is pi over 3. So if we know our unit circle stuff pretty well, then we can figure that out pretty easily. Okay. Inverse cosine of minus 1/2. Now, if we're talking about inverse cosine, we're looking for an angle between 0 and pi where the cosine is equal to 1/2. Okay. So our cosine, or minus 1/2. So our cosine is minus 1/2, and we're looking for an angle between 0 and pi. Now that's going to put us in the second quadrant because we want our x to be negative, right? So inverse cosine of minus 1/2 would be 2 pi over 3. Okay. Inverse tangent of 1. Now we're looking for an angle in this interval, minus pi over 2 to plus pi over 2, where the tangent's equal to 1. And as we saw in section 5.5, that is pi over 4. Okay. We're going halfway up the first quadrant. Okay, so just to kind of outline again what the angles we're looking for inverse sine, we can go like that, or like that. Okay. We can't go any farther. For inverse cosine, we go into the first and second quadrant, positive only. And for inverse tangent, just like inverse sine, we can go to the first quadrant or fourth quadrant only, going positive into the first quadrant or negative into the fourth quadrant. And that's, giving us this, right? So we can't go to 2 pi over 3 or 5 pi over 3 or anything like that. Okay, now let's look how we use inverse trig functions to find an angle in a right triangle. Okay, so here's our right triangle, and we have this angle. We don't know what it is, but we have these two sides. And in reference to that angle, that's the opposite and the hypotenuse. So we can say sine of theta is 10 over 50, which is 1/5. Okay, remember it's opposite over hypotenuse. Okay, so what we do is we take inverse sine of 1/5 to get the theta. Okay, and if we do this using our calculator, we would put it in degree mode to get 11.5 degrees. So we'd put inverse sine of 0.2, which is 1/5, and that would give us 11.5 degrees in degree mode. Okay. So here we'd use a calculator because we don't necessarily know what inverse sine of 1/5 is, right? Okay, now let's go a little farther with this. Let's say we want to take the cosine of the inverse sine of 3/5. Okay, now these don't cancel out, right? Because cosine and sine are different functions, right? And it's not sine of inverse sine, right? So here, what we're doing is looking at this. This inverse sine thing here is some theta. We can say it's some theta where the sine of theta is 3/5, okay? Which means that's the opposite over the hypotenuse of our right triangle, okay? If we're saying our sine is equal to 3/5, then we're given two sides of our right triangle. With our theta here, our 3 would be the opposite and our 5 would be the hypotenuse. And we just have to find that third side. Now we can use a squared plus b squared equals c squared to get 4 here, right? Okay? And then we're going to take the cosine of that angle. Okay, so we're going to take the cosine of this angle, and now that we have all three sides, we can just say cosine is adjacent over hypotenuse, so that's 4/5. Okay. Now we're looking at an angle between minus pi over 2 and plus pi over 2, right? So that's that would make sense, right? It would be a positive because we're in the right triangle. Okay, so it's an acute angle. Okay, so basically we're given these two sides of our theta, of our angle, of our triangle, where theta is here, when we're saying sine is equal to 3/5. Use Pythagorean theorem, a squared plus b squared equals c squared to get that 4, and then we can say cosine of theta is 4/5. In fact, we can do all the trig functions for theta now that we have all three sides. Okay, so we'll stop there for our discussion of inverse trig functions using right triangle approach. We'll look at some more varied examples in class, but we'll focus our discussion on mostly sine, cosine, and tangent. If we do inverse secant or inverse cosecant, just remember you're just flipping the number. It's just a reciprocal, so it's really not that difficult. Now I'll show you what we mean by that in class.